Hello everyone, welcome to our series of object-oriented programming concepts. Today we'll cover about the introduction to object-oriented programming, why object-oriented programming is needed with a real-life example, and what are the different principles of object-oriented programming. So let's start.
Before understanding what is object-oriented programming, let's understand why object-oriented programming is important and needed using a real-life example. Let's imagine you are working on a bank management system. What is the most important thing in a bank management system? It's the bank account. So you need to store a bank account details like account holder name, account number, balance, account type, etc. And you need to also have some functions to operate on top of this bank account data, like checking a bank account details, deposit and withdraw money, etc. Let's see how we can do this using a C, which follows a procedural programming paradigm. What is the procedural programming paradigm? That is covered in our previous video, so please go and check it out. So, but at a high level, procedural programming paradigms treats each step as a function, right? So procedural approach using C, how can we implement the bank account data, bank account structure, right? So we'll represent the bank account using a struct data type, and we can define the different properties of the bank account as a struct variables, right? And then we'll create some functions which will operate on that bank account struct, like deposit the money, withdraw, and then display bank account details, right? So what are the issues with this procedural approach? No code reusability. Why? Because if we want to extend the bank account for different account types, right? Current account, savings account, fixed deposit, etc. Right? So we might end up copying the code which might be common for different account types, like account name, account number. Then the functions which we have written, it is possible that we might create a different functions for each account type, because we'll need to create a different structs for different account types, right? So there is no code reusability here. No data heading. You can see that struct is directly accessed in any method. The bank account struct is accessed in different methods, right? So there is no restriction. There is no data security to restrict the access to the bank account struct and the properties of that bank account, right? So there is no data hiding. Tight coupling. So because the struct can be accessed from any function, it is possible that if any change at one place can impact the overall logic, right? So it introduces the tight coupling, right? Not efficient for complex logic. So as we discussed previously, like if we extend the bank account for different account types, then we might need to implement the different logic for different account types. Like withdraw logic for savings account will be different, the interest calculation will be different, right? So in that case, we'll keep on writing the new functions, right? Now this is not the way to represent the real world entity, which is bank account, using just a functions, right? So it is not efficient for handling such a complex logic, and not a scalable also, right? So let's understand how object oriented approach helps here. So object oriented approach binds the data and the functions under a data type called class, right? So the data here is basically the properties of the class, and the functions are uh, uh, the methods basically can access these attributes of the class, right? So the data and functions are tied together and put it into one unit called class. And when we create a variable of this class, which is called as object account1, so for different account like account1, account2, then the special method gets called automatically. That method is called as a constructor. So in most of the programming languages, the constructor name will be same as the class name, but there will be in some of the programming languages like Python, the constructor name will be different, like in it is init in a Python, right? And it gets called automatically when we create a new variable of this class type, which is object, and it primarily helps to initialize the object and the properties around it if required, right? So what benefits we are seeing here? It is hiding the data. So controlled access to data only via class functions. So you can see balance is only accessed via the functions which are defined as a part of this bank account class, right? Reduce tight coupling, because now the data and functions are tied together under the one class unit, account class unit. So any changes in this class will be mostly limited to this class only, right? So the tight coupling is reduced here. Then what are other benefits, right? Let's see this example where say new account type is added using the savings account class, right? And it is inheriting or basically using the properties from the uh, general base bank account class, right? You can see it is reusing the code. You can see here there is no deposit method or withdraw method or no account holder name number, right? It is using from this class. It is inheriting the properties of that class, right? So it is reusing the code. Then it is handling the complexity, because it is able to add the new account type easily, and the specific logic for that account type can be added into that account type class, right? For example, apply interest. So it is handling or simplifying this complexity of this data structure, right? And it helps it to scale, right? Abstraction. Now the bank account use a way to just access the balance using get balance method or some interface, right? We don't need to worry about how that balance variable is stored in internally, whether it is double int or whatever it is, right? How the interest rate is applied on top of it, how the data is fetched from the backend, right? So it abstracts that implementation complexity, right? And it just provides the interface like get balance to get the balance, right? So that this type of complexity is abstracted. Flexible. Now we saw, right, how the savings account type class is added easily, right? So the other account type classes like current account, fixed deposit account can also be easily added, and the current implementation of the bank account can be extended easily. So we can see the different benefits of the object oriented approach or the procedural approach, right? And it helped us to define the bank account very easily, right? So because of this, object oriented approach is widely used in industries for a large and complex projects. Now let's understand the class, right? Till now we understood what is object oriented programming, and we talked about classes multiple times in a previous slides. But what exactly is a class, right? So class represents the template or design to create a multiple objects, right? It is just a template, right? So what does that template says? It represents how the data should be present in object, like what type of fields should be present, what type of methods should be present which will access those fields, right? So it is just a template, right? So for example, in this case, this is not a real bank account yet. We need to create a account object or the variable of this bank account class for actually making that making that as a real world entity, right? So in a simple word, think of it as a other data types like int, float, char, etc., but customized to store the multiple values and having a methods to access those values, right? So it is a data type only, like similar to int, float, char, but this data type is a user defined data type with the customization, right? So let's understand the object. Now we understood what is the class in a previous slide. So class is a data type, then object is a variable of that data type, right? So for example, when we say int a, right, so we int is a type and a is a variable of that type, right? So similarly, when we say bank account account one is a variable of type bank account class, right? So this variable is called as an object, right? So each object can be initialized with the value specific to that object, right? For example, we are creating the bank account real world entity with the details like the account holder name, account number, balance, etc., right? So it represents the real world entity created using the class template, right? And the actual memory gets allocated when the object is created. Basically, we are creating object, then only the memories required for the fields of the class gets created in that object memory. So In a simple world, object is a variable of type class, right? The class is a data type here, which is bank account, and account one is a variable of that bank account class type, right? Let's understand the class variables and instance variables. So if you see, right, what is class variables? So class variables are basically the common variables or the global variables which are uh, common across all the objects. For example, if I have an account in a Bank of India and my brother also have account in Bank of India, so the bank name is common for us, right? We accounts are different, the objects are different, but the bank name is same, right? So the class variables are in a different languages it is declared in a different way. In a C++ it is declared using static keyword, but it is a shared by all objects of the class, right? The bank name is same for all bank accounts in that bank, right? So memory is allocated only once because it is a common and global variable. Every time when the new account is created, this will not be created every time, right? It is common, so it is in a class memory, right? So it is a global and shared across all objects, and it is accessible using class name and the variable name, right? In a C++ it is accessed like this. In different languages it might be accessed in a different way, but the base point here is that the class variables are used when there is a requirement to represent some common data which is shared or which will be common across all types of that class, right? Opposite to that, the object or instance variables are very specific to the object, right? For example, in this case, these highlighted ones are the variables or the fields of belonging to each object, right? For example, if we create the two objects, account 1 and account 2, you can see the properties are different for both the accounts, right? And because of that, these fields will be separate for the account 1 object and account 2, right? Uh, so it is unique for each object. When the object gets created, the memory for this variables are also allocated as a part of that object memory, right? So it is a separate copy per object, right? And when the object is deleted or destroyed, right, or cleaned up, this variable also get cleaned up because they are a part of object memory. So the object is also called as instance. That's why they are called as a object variables or instance variables. Let's understand the principles of object-oriented programming. There are four principles of object-oriented programming: encapsulation, abstraction, inheritance, and polymorphism. Let's understand the encapsulation. What is encapsulation? Encapsulation is bundling of data, variables, and methods that operate on that into single unit. That is a class, right? You can see this is called encapsulation. The data and the functions are encapsulated under the unit bank account class, right? Restricts the direct access to some of the objects components. So you can see here, you can see the private, public, right? This is called as access modifier. So what exactly it is, we will understand that in a detail in upcoming videos. But using this, it restricts the direct access to the variables, right? So it provides the data security, right? That is the feature of encapsulation, right? So the encapsulation focuses on a data security or the data hiddeness, right? And that helps us to, and that can be done using the access modifier, right? So, and the access to it you will be done only via the functions of this class. So this is a controlled access, right? So this is what the encapsulation is. So it restricts the direct access or hides the data for providing the better data security. What is abstraction, right? So abstraction is basically hides the complex implementation detail. So that is the difference between abstraction and encapsulation. Encapsulation works on a data hiding or providing the security to data, but abstraction uh, it basically hides the implementation details or the complex logic details, right? For example, like basically it will just provide you an interface to get the data instead of the telling how the data is stored or computed internally, right? For example, method called get balance. When you go to the ATM, right, when you click on check balance, you just interacting with this get balance method, right? You don't need to know how the balance is stored, whether it is stored as a double or not, in which database it is stored. When you click on the get balance, how that data is fetched from the database. You don't need to as a user, we don't need to know about that, right? That complexity, implementation complexity, we don't need to know. We only need to basically access that balance using this interface, get balance, right? So this is the difference between encapsulation and abstraction. Abstraction is about hiding the implementation logic, complex implementation logic. Encapsulation is basically providing the data security by restricting the access to the data within the code itself, right? Next is inheritance. So inheritance, basically it allows one class to inherit or use the attributes or methods from another class, like parent child relation, right? So the child inherits the properties from a parent. So why it is important? It promotes the code reusability and avoids redundancy. Let's understand from this example, right? So we have this base class called bank account, and from the bank account we created one more class for specific account type, which is savings account. You can see that we did not define any methods here, right? We did not define the deposit or get balance method again here, right? Because they are getting inherited from the base class. And the balance, which is a variable, it is common. It is also, you can see it is used from the base class, right? So it is doing a code reusability, right? And because of the inheritance, which provides you the parent child like relationship, what are the properties of this general bank account are getting inherited to the child account, which is a savings account type, right? So bank account is a parent class, and savings account, which is inherited or extended, is a child account, right? Next principle is polymorphism. So polymorphism means that poly means many, morph means forms, so many behaviors. So as the name says, it allows one interface to behave differently based on the object or data type. So for example, let's take our example only, right? We behave differently in a class, we behave differently at home, we behave differently with friends, right? So we are a very good example of polymorphism, right? So similarly, if we see this bank account example, bank account is a parent class and the savings account is a child of that bank account, right? It's a specific account type class, right? You can see withdraw method is same, right? So it is the same method, but the logic is different based on the account type. For the general account types, the balance can be withdrawn till it is zero, but for savings you can withdraw the balance till at, so you need to have minimum 1,000 balance, right? So you can see that even though the method is same, in a child class you can override its behavior, right? So when you create the bank account object, so let's say you created the savings account, the behavior of the withdraw method will be different, right? So one method but many behaviors, right? So this is the example of polymorphism, right? So depending on to the object type, if it is a savings account object type, the withdraw behavior will be like this, and for a general bank account type, the withdraw behavior will be like this, right? And if we create one more class, like let's say currents account, the withdraw behavior will be different there, right? So uh, it the polymorphism principle of the object oriented programming allows us to give this flexibility to define the behavior based on the different object types, right? There are two types of polymorphism: compile time and runtime. We will understand this polymorphism types in a detail in upcoming videos, right? But these are the main the core four principles of object oriented programming: encapsulation, abstraction, inheritance, and polymorphism. So we understood about why object oriented programming is needed, uh, and compared it with the procedural approach. And then we understood about the class and objects, class variables, instance variables, and the four principles of object oriented programming. This will act as a base knowledge for understanding the next topics, which will be in a much more detail on top of this the topics which we discussed today. So hope you understood the video and explanation. If you like the video, please share and subscribe. Thank you.
Hope you understood the explanation. This will act as a base knowledge for our upcoming videos on object-oriented programming series. If you like the video, please share and subscribe. Thank you.